learners. Welcome to Science, where learning becomes easy once we explore. Today, we are going to learn about the concept of uniformly accelerated motion. But before that, have your pen, your notebook, and your self-learning module. For me to know if you have prior knowledge for our topic for today, let us answer the following question. Number 1. It is important for motorists to know the speed of their vehicles when driving. Which device is used to determine the speed of a moving vehicle? A. Barometer. B. Odometer. C. Speedometer. D. Thermometer. Correct answer is letter C. Speedometer. Number 2 question. In a body exhibiting a uniformly accelerated motion, which of the following quantities is constant? A. Acceleration. B. Speed. C. Velocity. Or D. Time. The correct answer is letter A. Acceleration. Question number 3. Which of the following statements is not true about an object in uniformly accelerated motion? A. Velocity is constant. B. Acceleration is not zero. C. Acceleration does not change. Or letter D. Velocity changes at a constant rate. The correct answer is letter A. Velocity is constant. Question number 4. Uniformly accelerated motion is evident in our everyday living. Which scenario or object exhibits uniformly accelerated motion? A. A falling leaf. B. A ringing cell phone. C. A sleeping cat. Or D. A hanging wall clock. The correct answer is letter A. A falling leaf. Question number 5. Speed limits vary with the type of road and area. Which of the following statements is not true about speed limit? A. It permits vehicles to move in uniformly accelerated motion. B. It regulates the flow of traffic in different areas. Or C. It minimizes vehicular accidents on the road. Or D. It restricts the speed of vehicles. The correct answer is letter A. It permits vehicles to move in uniformly accelerated motion. So, are you ready to learn something for today? Let's dive into our learning competency and lesson objectives. Learning competency. Describe the horizontal and vertical motions of the projectile. Lesson objectives. Letter A. Define uniformly accelerated motion operationally. Letter B. Cite examples of bodies that exhibit uniformly accelerated motion. Letter C. Value the importance of following and observing speed limits on the roads. In grade 8, you learn about Newton's second law of motion, the law of acceleration. According to this law, the net force is equal to the product of the mass of the object and its acceleration. Can you state this law? Let's have a simple activity to refresh your minds. State the second law of motion by completing the paragraph. Choose your answers from the two words inside the parentheses for each number. Newton's second law of motion. The law of blank, inertia, or acceleration. The acceleration of an object as produced by a net force is blank, directly or inversely proportional to the magnitude of the net force in the blank, same or opposite direction as the net force, and blank, directly or inversely proportional to the blank, mass or weight of the object. The correct answer for number 1 is acceleration, number 2 directly, number 3 same, number 4 inversely, and number 5 mass. It is good that you can still recall the law of acceleration. Remember that the larger the force applied to the object, the larger its acceleration. Usually, the acceleration of the body may change and vary from time to time due to several factors. If that is the case, when do we say that the acceleration is constant? In this lesson, we will focus on describing uniformly accelerated motion qualitatively. Are you familiar with this blue uniform man who usually positioned at the busy streets of Tuguegarao City? You might have seen them as you cross the streets going to your destinations, or on your way going to SM, Robinson's, or your friend's house. Who are they and what do they do? They are the Tuguegarao City Traffic and Parking Management Officers. They are also usually called Blue Boys. They play a crucial role in maintaining the flow of traffic and in implementing laws and rules and regulations on the road that every motorist should follow. They may also be considered as frontliners amidst the COVID-19 pandemic, as they assist soldiers and police officers in checkpoints around Tuguegarao City. Speed limits are observed on roads. They vary and depend on several conditions. Speed limits for highways are different from speed limits on small avenues and streets. This prevents vehicles to speed up or accelerate unnecessarily in our busy streets, as they are being monitored by our Tuguegarao City Traffic and Parking Management Officers. Acceleration is defined as the rate of change in velocity with time. It is a vector quantity having both magnitude and direction. Acceleration of vehicles usually changes from time to time. A vehicle may speed up as it travels to highways or slow down as it approaches an intersection. It should also halt when the stoplight is red and eventually accelerate when the light turns green. We can say that most type of acceleration that we observe is not constant or non-uniform due to these factors. When you are riding a vehicle, you can say that it speeds up or slows down based on its speedometer. A speedometer indicates the speed of a vehicle. It is usually combined with a device known as odometer that records the distance traveled. Let's assume that you are riding a vehicle and you observe the speedometer readings. What can you say about the readings on the speedometer during each minute? What can you infer from the data in the table? This means that the vehicle speeds up. Every minute, there is a 1 kilometer per hour increase on the speed of the vehicle. The increase for every minute is constant. Therefore, we can say that the vehicle has uniform acceleration. The vehicle in the example above exhibits a uniform or constant acceleration. It is a type of motion in which the velocity of an object changes by an equal amount in every equal period. In uniformly accelerated motion, the value of acceleration is constant, meaning it does not change. The velocity changes but at a constant rate. Toss a coin upward. Does it stay up? What makes it go down? Gravity pulls the coin down. Things that are thrown upward will go down because of this force. Gravity also pulls us towards the earth. That is why we are not being thrown outside space. When you climb a high place, you go against gravity. When you are on a high place and you go down, you are moving toward gravity, so you use less force. Same is true with free-falling objects. Objects at a free fall also exhibit uniformly accelerated motion. The acceleration due to gravity, which is 9.8 meter per second square, neglecting air resistance, is a constant acceleration for all falling bodies, regardless of their mass and weight. All objects on the Earth's surface are being accelerated toward the center of the Earth at a rate of 9.8 meter per second square. This means that if you raise an object above the surface of the Earth and drop it, the object will start from rest and its velocity will increase by 9.8 meters per second for each second it is falling toward the Earth's surface until it strikes the ground. In general, a uniform accelerated motion is the one in which the acceleration of a body throughout the motion is uniform. It can be observed in either vertical or horizontal dimension and also in 2 dimensions. We will prove these examples of uniformly accelerated motion on the next session, mathematically or quantitatively. This time, you are going to answer Activity 1 entitled Am I in UAM? The objective of this activity is to identify bodies or objects that exhibit uniformly accelerated motion. Here are the things that you need to do. First, analyze each scenario. Second, write UAM if it exhibits uniformly accelerated motion. If does not, write non-UAM. Number 1. A bike that is at rest. Number 2. A boy holding a book. Number 3. A girl walking leisurely. And number 4. A hanging picture frame. And number 5. A rock falling from a cliff. Number 6. A fruit dropping from a tree. Number 7. A rolling ball on an inclined plane. Number 8. A man standing still in an escalator. Number 9. A car increasing its velocity at a constant rate. And number 10. A truck running with a constant acceleration. Were you able to identify the bodies or objects that exhibit uniformly accelerated motion? Oh, that's great! When can we say that an object exhibits uniformly accelerated motion. Wow, you did a great job. So let's proceed to activity number 2. The second activity is entitled Observing Speed Limits. The objective of this activity is to value the importance of following speed limits on roads. Here are the things that you need to do in doing this activity. First, make or write an open letter addressed to drivers and motorists. Second, make an appeal to them to follow speed limits. And third, explain the consequences of not following such. And fourth, integrate what you have learned in uniformly accelerated motion. And lastly, cite examples to deliver your message clearly. Were you able to write an open letter addressed to motorists and drivers in observing speed limits? If yes, you did a great job. Now, come to think of it, what do you think will happen if all vehicles on the roads are moving in a uniformly accelerated motion? To sum up our discussion, let's have this game entitled Fact or Bluff. This time, to test whether you learn or you understand the lesson, let's have our post test. Congratulations, science-minded learners! I hope you will apply and transfer the knowledge that you have learned about uniformly accelerated motion. This is Teacher Junmark saying that science becomes easy once you listen to me attentively.